Just so y'all know, I'm pretty happy with my little stand I made now. Okay, so the last one for 6.1, starting at problem number 32, converting decimals converting degrees, minutes, and seconds into decimals and then going backwards. We'll do that mostly because it's one of the major learning objectives of this class when you look it up on the state of Virginia, but most people do it with a calculator. We'll get into that later. All right, so 32, 52 degrees, and 15 minutes. I want to convert that to straight decimals, which is normally where I work anyway, because I'm not a surveyor and not a boat captain or a ship captain. So keep the 52. The whole number stays the same. Just set it over to the side, write it in the margins, do something to keep track of it. Now that 15 minutes, there are, in 1 minute of a circle, in 1 degree of a circle, there are 60 minutes. So this is just a fraction set up. 15 minutes divided by 60 minutes gives me 0.25. That's my fractional degrees, 0.25. So the answer to 32 is 52 that I kept to the side, 0.25. On 37, I got 49 degrees, 38 minutes, 46 seconds. Same setup. Keep my 49 degrees off to the side because I'm going to use it just the way it is. 38 minutes. There's 60 minutes in a single degree, so 38 divided by 68 gives me the decimal 0.6 repeating threes. Now, the 46 seconds. In a single degree, there are 60 minutes, and each minute has 60 seconds. So I need to take my 46 seconds and divide that by 3,600. That's 60 times 60. That gives me the little decimal of 0.012 repeating sevens. Add those two decimals together and gives me a 0.64 or 65, depending on how your round off goes. So I've got 49.64 or 49.65. Either one of those is fine. Now, to go from decimals back to minutes and seconds, I don't know why they don't teach it in math class. I love this little chart they do, this little line chart in chemistry. I think it's the most awesome thing. I don't know why we haven't stolen it. So, the 20.14 in number looks like 45. No, I guess it's 44. In number 45, I have 20.14. Keep my 20, same setup. It's going to go off to the side later. It'll be the same degrees no matter what. I want to make my 0.14 into minutes and seconds. So, draw my little T chart. If I could do them all at once, but I don't for you guys. 0.14 degrees, and then my second spot gets 60 minutes over 1 degree. Multiply straight across the top. Cancel out the degrees. Now I get 8.4 minutes. The 8 you keep. I have 8 full minutes. I need to know how many seconds that 0.4 is. So same setup before. 0.4, put my little minutes thing. There are 60 seconds in 1 minute. I'm not talking about degrees, I'm talking about seconds and minutes. I get 24 seconds, and then string that all together. 20 degrees, 8 minutes, 24 seconds. Unless you are going to do surveying, unless you are going to go into sailing as either an in-depth hobby, or I understand being a ship captain is kind of lucrative, kind of like being a pilot. It is unlikely you will need to do this in any other fashion than with technology or a calculator. So, but we've done it. We followed the letter of the law. Let's see, 55. This is just plugging stuff in the calculator. Make sure you're in degree mode. So then you can just do cosine 51 and hit enter. Spits you out a decimal. Cotangent of 71. I don't know if you noticed or not, the calculator that I default to, the one the schools have, the last one you can use in a standardized test is this one. There is no cotangent. There's no cosecant. There is no secant. You have to learn to trick the calculator. So what I do is the tangent of 71 degrees, hit enter, turn it upside down. And there's a little inverse button on there. If you look, you got second alpha math, and x to the negative 1, turning something upside down. Of course, in a little bit, math people are notorious for this. I'll have this notation on the calculator for turning stuff upside down or making a reciprocal, and then I'm going to use it for something that totally doesn't mean that. So you can feel outraged with me. I like to feel outraged. I like to pick on math people. Still plugging stuff in. Okay. Yep, here we go. Almost immediately, we're going to turn some stuff over without turning it over. On to 71. Still plugging stuff into the calculator. Except, I do not want to know the sine of 0.5125. I want to know at what angle. That little theta in there is kind of like an X or a question mark or a blank. I want to know at what angle is the sine going to be 0.5125 on this calculator. Even though they did give you this as being the reciprocal. Now we're going to pretend like we've been perfectly clear. And this little, above the sign, there's a little sign to the -1. That does not mean turning the sign upside down. That means now that I want to do the inverse sign. I want to undo the sign, just like square root and squared are opposites. Multiplication and division are opposites. Sine and sine to the -1 on this calculator are opposites. And I'm fairly certain that most math instructors you will run into, unless they teach high school or they just really are good listeners, and a lot of them aren't, they do not realize they have given you two entirely different options for a single way of looking at things. That is infuriating, especially if you're already struggling to change to math language. They totally gloss over it. So, now, when I say sine to the -1 in this class, it means inverse sine. I try to stick to inverse sine. When we do all this later and it's a big deal, I stick to inverse sine. When I did these notes, I did it with the calculator kind of to point out to you that there's a glitchy thing that a lot of math people act like you're stupid for not noticing. No. They've just forgotten that they're deliberately confusing. So on this, I tried to put in a couple of the buttons where you put the buttons. When you turn to the next page, and it goes to not to decimals, I actually wrote out the English for what you're trying to do, like on 83. Really what you're doing is at what angle, theta, is the sine square root of 2 over 2. You can do two things. You can play it in that calculator. I have my chart. Let's see, for sine, I have a lot. For sine, I looked down for the square root of 2 over 2, and then I looked over to see what angle it was. With this right here, I think this is just a kind of a foreshadowing for what's to come. Get through this little bit. There's a few on the test. Don't worry about it. There's a whole section on it. We'll do that later. And that's the end of 6.1.